In this video, we're going to look at solving a quadratic equation by factoring. But before we do that, we need to look at something called the zero product property. Now, I have the beginning of the zero product property written here. Can you figure out what would be after the word then? If a times b is equal to 0, then what? What would have to be true about a and or b? Think about situations where two numbers multiply to be 0. What does that look like? You got it? I think you may have it. One of those numbers has to be 0, right? If a times b equals 0, then either a has to equal 0, or maybe b could equal 0, or maybe both. Maybe they're both equal to 0. But at least one of them has to equal 0, right? All right, so that's what the zero product property says. Now, how can that help us out? Well, let's say we have a quadratic equation x squared minus 7x plus 12 equals 0, and we want to solve that. We want to figure out what values of x will make this equal to 0. So how does this look like the zero product property? Well, right now, it doesn't really look like the zero product property, except for the fact that it's equal to 0. That's good, but we don't have something times something equals 0. We have three terms added together to equal 0. So this is where the factoring can help us out. Can we factor this trinomial? If we can factor this trinomial, then we do have something times something equal to 0. Let's give that a try. This looks like one of those easy trinomials with a 1 in front of the x squared. So all we really need to do is figure out what multiplies to be 12 and adds to be negative 7. Now keep in mind that only works, that little strategy only works when there's a 1 in front of the x squared. We can think what multiplies to be 12 and adds to be negative 7. And those numbers are, you got it, negative 3 and negative 4. All right, so that means we're going to have x minus 3, x minus 4. It doesn't matter what order. I could have put x minus 4, x minus 3. So now we have a times b equals 0. And yes, this a is not just one number. This a is x minus 3. And this b is x minus 4. Okay, b doesn't have to be just one number. It can be a whole expression. In this case, x minus 4. So we know that either a has to be equal to 0. In this case, x minus 3, this factor has to come out to be 0. Or b has to be equal to 0. In this case, the factor x minus 4 has to come out to be 0. Now, what value of x will make x minus 3 be 0? We could kind of do that in our head, but if we couldn't, we could just add 3 to both sides. And we see if x is 3, then this factor will come out to be 0. Now, if x is 3, this factor is going to come out to be negative 1. But it doesn't matter, does it? Because it's going to be 0 times negative 1 is 0, so that would work. Let's do the other factor. If I add 4 to both sides, I get x equals 4. So if I let x be 4, this factor would be 0, and this factor would be 1, and that would still multiply to be 0. So that means we have two solutions. So we could put our answer in a solution set like that. We have two solutions to this equation, x squared minus 7x plus 12 equals 0. And we could actually check that by plugging it into the original equation. We could check that. We have our original equation is x squared minus 7x plus 12 equals 0. I'll just check one of them. You could do the other one if you want. Let's check x equals 3. So we're going to put 3 in for x into the original equation. Is this going to come out to be 0? That better. Let's do our order of operations here. And we get negative 12 plus 12, and that is 0, and that does work. And you could do the same with 4, and that would also be a solution. So the steps that we're using to solve this using factoring, solve a quadratic using factoring, first, we need to make sure there's a 0 on one side of the equation, and that's because the zero product property needs to be equal to 0. Then we're going to factor. And the reason we're going to factor is because we need it in the form of this a times b, and that's what the factoring does. Then we're going to set each factor equal to 0 and figure out what values of x will make that equal 0. All right, let's try one more. Why don't you give this one a try? 2x squared minus 7x minus 30 equals 0. Maybe pause the video and see if you can factor this out. Is it equal to 0? Yeah, it's already equal to 0. What if it wasn't? I mean, I could have something like maybe instead of minus 30, maybe I had this equal 30. All right? So now it's not set equal to 0. Let's just do that. Then we'd have to set it equal to 0. All right, give it a try. Unpause the video when you're done. So the first thing we want to do is we want to minus 30 from both sides to get 0 on one side of our equation. We need that because of the zero product property. Now we need to change this into a times b. So we need to factor this trinomial. Now there's lots of different ways to factor trinomials, so you have to use whatever skill you use. I like to use sort of a guess and check method. I know that 2x times x has to be 2x squared. I like to use a little modified version of the guess and check method where I multiply the 2 times the negative 30, and that gives me negative 60, and then I figure out what multiplies to be negative 60 and adds to be the middle number. The middle number is negative 7, the b value. Now we might need to mess around with this a little bit, but it turns out that 12 times 5 is 60. So we would have negative 12 plus 5. That would multiply to be negative 60 and add to be negative 7. Now, this isn't one of those easy trinomials because there's a 2 in front. So you don't just put the negative 12 and the 5 here. The negative 12 and the 5 are going to be the result of multiplying the outside terms and the inside terms. One of them is going to be a negative 12 and the other one's going to be a positive 5. Now, I can see that the outside term is going to be 2 times something. Well, that's not going to be 5, right? Because these are going to be integer numbers here. So this is going to end up being the negative 12. So that tells me this has to be a 6. Okay, and that means the inside part is going to be 5. So that tells me that this number has to be a 5. Now that makes sense because those two numbers have to multiply. These two numbers, 5 and 6, have to multiply to be 30. All right, so that's working. I need to put a negative in here. This needs to be a negative 12, and that needs to be a negative 30. So it looks like I make the 6 negative and the 5 positive, and there we have it. Sometimes that's the hardest part right here, the factoring. Now, let's go to the next step. We're going to set each factor equal to 0. So I have these two things that multiply together to be 0, these two factors. So either the first factor has to come out to be 0, or the second factor has to come out to be 0. So in order for the first factor to come out to be 0, let's solve this and see what we get. It looks like x is going to have to be negative 5/2, or negative 2 1/2. In order for the second factor to come out to be 0, it looks like x is going to have to be 6. Okay? So these are the two solutions, and we could write our answer in a solution set if we wanted to. These are our two solutions. This is not an ordered pair. This is a list of solutions. So I could go back to the original equation if I wanted to and check. Let's do 6. Let's check x equals 6. So I'm going to put 6 in for these x values, and let's see if it works. 2 times 6 squared minus 7 times 6. That's going to be 2 times 36 minus 42. 2 times 36 minus 42. This is supposed to come out to be 30. I'm running out of space here. Bad space management. Let's see. 2 times 36 is 72. Take away 42 is 30. All right, so that works. All right, so this is a very good method for solving quadratic equations as long as they factor. But what if the quadratic equation doesn't factor? Well, you'll learn another method to solve those kind of equations in the future.